All right, so from our last video, we found this relationship between work and energy for rotation. So we're going to go ahead and put this to use in this problem. So we have our work, which is going to be a force times our distance equal to our kinetic energy after and before the initial and the final kinetic energies. So our final kinetic energy is going to be 1/2 I omega squared. And our initial, because it started at rest, probably starts at rest, our omega is going to be 0, okay? So now we can solve for omega final, and it's going to be 2fd over I, and then we'll square root it. So let's see. We have 2 times our force, which is 50 newtons. Then our distance, which is going to be that 1 meter, that 1 meter of string, over I, which is going to be 2.5. Is there something missing here? There is, isn't there? Oh, maybe not. Okay. 2.5 times 10 to the negative 3 kilogram meters squared. Okay, and then I'll go ahead and square root that in my calculator. So let's do this. We got square root of 2 times 50 times 1 divided by 2.5 times 10 to the negative 3. So our omega is 200 radians per second. Okay, so this is our angular velocity. Okay, so now we're going to quickly talk about power just for rotational motion. Remember that power, we found that from work. It's work over time, so power is equal to tau omega, and we're just going to use that equation. In this example, we have a boat engine operating with this amount of power, watts, which is joules per second, and it's running at 300 revolutions per minute. What is the torque? And so we would use this equation. P is equal to torque times omega, our rotational velocity. And so we want to find torque, so that means it'll be our power over our rotational velocity. And we will need to convert this, so 2 pi rad over revolution times for 1 minute, 60 seconds, okay? So then tau is going to be 9.0 times 10 to the 4th watts over that 300 times 2 pi over 60, and that'll be in radians per second. Okay, so let's take that bottom piece first. So 300 times 2 pi over 60, and then we'll say 9 times 10 to the 4th divided by that answer. So we get a torque of 2.86 times 10 to the 3rd. And this is going to be in, what were the units of torque? I forgot off the top of my head. Why can I not remember? Well, shoot. Newton meter. Yeah, right. Okay. Sorry about that. Newton meter. Okay. Oh, is that the end? Okay. I thought I had another slide in here to kind of show all the relationships between everything, but I may have already done that. Maybe that's why. So in your textbook, they have this section on rotational and translational relationships. So let me make it bigger. Okay, yeah, it's basically the same thing except for they've added a couple of lines here for your kinetic energy, and so forth, your power and so forth. So that was a really quick rundown on all of this stuff, I feel like. But I tried to touch on what you'll need to know for your homework, and so forth. Okay, so if you have any questions, feel free to contact me. I will have other supplemental videos up, so that they should help as well. And maybe more, maybe they simplify it a little bit. This may have been a little complicated. I do know off of this textbook, sometimes it gets a little bit complex. So hopefully you guys were able to follow that. And again, let me know if you have questions.